Hello again, marvelous math students. Today we're going to be talking about scatter plots and line of best fit. Line of best fit is what we're going to use to represent some data in a scatter plot that doesn't have everything in a perfectly straight line. So a scatter plot really can be just a whole bunch of points that are truly scattered all over. Sometimes there's no relationship. Here we even have, I just have a random scatter plot that really doesn't make any sense at all. We have an x-axis and a y-axis, and they should be labeled somehow. Also, just so that you're aware, they call the x-axis the independent variable. When we talk more about functions, we'll get into that a little bit more. And the y is going to be the dependent variable. That's not really that important for this lesson. But all of these points that are graphed have x's and y's, and again, the labels on each axis will be helpful for that. So, oh, I don't think that I got where I needed to be, sorry. There we go. All right, so when we're looking at different scatter plots, I want to know about the correlation. The correlation is really just the relationship. How much the x and the y information are really associated, or how linear this would look. So a positive association or a positively associated set of data would be where I have, as the x's are increasing, the y's are also increasing. It really just means that it's going to go from the bottom left to the top right. So here's what it would look like. If I would have a scatter plot with these red points that are on there, the line that I have drawn there kind of represents where that data is. That's a positively associated group of data. I want you to also notice it's a positive slope. That's what I want you to be thinking about. If it's got a positive slope, it's a positive association. As it goes uphill, that's a positive association. Then when I look at a negative association or a negative relationship, as one thing increases, the other thing decreases. So as I go farther to the right, I should be going downhill then. So as the x's are increasing, the y's are decreasing. Or I can say as the x's are decreasing, as I go to the left, the y's are increasing. So upper left to bottom right, again, it looks like a negative slope. This is, again, a scatter plot. Notice that the line that I've got drawn represents where the data is, but it's not going to touch every single point. This is not a game where you get a higher score if you have a line that touches more points. I want to have a line that's representing where that data is. That's what a line of best fit is. If I have something with really no correlation, there's really no relationship between the two. You can see these points, there's really no clear place that I should draw a line. There's approximately no correlation. If you're using a graphing program on a computer, it could take this and it could sort of draw in a line to represent it, but it's really just crunching some numbers. It doesn't really make sense in terms of the data that we have here. So when I talk about a line of best fit, I want to be able to draw the line that would represent the data the best that I can. So in the first one, I have a negative correlation. I guess I don't really know why I have my graphs in this order, but this is a negative correlation because the red line is going downhill. And you can see that it's not touching every single point. It's touching a couple of points. It goes through that point. It goes, I guess it sort of touches that one. It's really close to a couple other points, but it really does represent where that data is. In the positive association that I have on the right, again, it's touching a few points. It goes through this point, it goes through this point, it's kind of touching that point, but I'm not trying to like line up a ruler to see where I can get the most points lined up for one line. It's really more of a representing where the data is. So if I have a graph like this, and I want to know where to draw the line. Hopefully, as we talked about this already, you can see this is a negative association. If I just sketch this freehand, I would want my graph to go sort of, I don't know what happened there, sorry about that. it would go like that-ish. Oh, that's really not very good. However, here it is drawn much better. Oh, actually, I'm not too far off, I guess. So there's where my line really should be. It's representing the data. I've got some points above the line. I've got some points below the line. I might go through some points. I might not touch a single point. But if it's where the data is, that's the best I can do. So I want you to take a look at this one and tell me, is this a good line of best fit? It's kind of taken my line and pulled it lower than I would like it to be because of this one point down here. And I hope that this word makes sense to you. That point is actually an outlier. It doesn't really make sense with the rest of my data. So this line that's drawn is really not a good line of fit, right? That one point is an outlier. It just shouldn't even be considered when I'm trying to draw my line. A better line would be sort of parallel to the one that's there, but it should be more like that, to have some points above it and some points below it, not just have it pulled out of place because of the one point. So let's take a look at this one. I want to place the line of best fit. So again, I can draw this, and my line should be a positive association this time, a positive slope, probably about there. That's not too horrible, I guess. Let's take a look. Yeah, mine's not too far off. It should be slanted a little bit less steeply, but pretty close. I want to know now if we have a good line of fit or not. This is the same data in these two graphs, and I want to know which one is the better line of fit and what's wrong with the other one. So I have on the left, I have 1, 2, 3, 4 points to the left, I guess, above the line, and 4 points to the right. And on the graph on the right, I have the same thing. 4 points above, 4 points below. But clearly, the one on the right is representing the data. The one on the left kind of split the data to have half and half, but it doesn't really represent where that should be. So if I take a look at this graph, I've got a scatter plot that shows the relationship between the number of games played and the number of tickets that they win. So this must be at like a carnival game. And I want to know which of these lines below has the same data, it's the same graph, but which one has the best line of fit. So as I'm looking at these three, clearly I can see B is not correct. So I'm looking at A or C. They're very similar, and the line does sort of go through the data, but I would say that C is much better in terms of actually representing the data. In line A, this line is too steep. It's down below all of these points, and it's above a bunch of points here that's not really going kind of through the center of them, like the one in C is. So C would be the winner in this case. In number 4, again, same graph 4 times. The first one just doesn't have a line. The hours spent shopping and the money that you have left. So clearly this person is spending a lot of money. And we want to find the graph that represents it the best. Again, B is out of the running. It's got a clear negative association, and that's a positive line for a slope that we've got there. C, the line is just too high. I have 1 point above and a whole bunch of points below. A has a better mix of points above, points below, representing where that data is. So part of your assignment is going to be, can you recognize the line of best fit? The other part is going along with, we were just graphing systems of equations. I also need to be able to come up with the equation of the lines. So let's review that a little bit. If I give you graphs like this, I should be able to find some points on my graph so that I can count my slope and I can find my y-intercept, right? Those are always the 2 important things that I need. My slope in this case is negative. It's going down 1 and over 2, over and over again. So negative 1/2 is my slope. My y-intercept is right here at -3, so my equation is y equals -1/2 x minus 3. In number 2, also a negative slope. This one is a little tricky. Some people say, okay, I've got a point right here. Oh, that one's pretty close. If I just draw a big point, yeah, that's not really what we want to do. We have to find places where it's actually going right through the grid mark. So that'll be here and up here. So this is a negative slope, but it's going down 1, 2, 3, and then sideways 1, 2, 3, 4. So my slope is a -3/4. And my y-intercept right here is at 1. So my equation is going to be y equals -3/4 x plus 1. In number 3, I have a positive slope this time. And this time it is going right through all of those grid marks. My slope is up 1/1. So my slope is 1. My y-intercept is at -3. So my equation would be y equals, you can say 1x, or you can just put x, right? You can even put a 1/1 if you wanted to, minus 3. And for number 4, I have a negative slope. Finding some points on this one. This is going down 1, 2, 3, and over 2. And my y-intercept is at 1. So my equation is y equals -3/2x plus 1. And for these last examples, positive slope in number 5. Here are some points, kind of far apart this time. This is going up 1 and over 1, 2, 3, 4. So my slope is 1/4. My y-intercept is at +2. So y equals 1/4 x plus 2. And for my last one, similar graph, because this time my slope is a negative, but it is a -1/4. So down 1 over 1, 2, 3, 4. So it's the same steepness as my last graph, but it has a negative slope. And my y-intercept is actually 0 on this one. So you could say y equals -1/4 x plus 0 if you want to, but you really don't need the plus 0. So today, one side of your worksheet has problems with line of best fit, answering some questions about it, finding the right line that's drawn, and then the back side of the worksheet is writing equations of lines. So the answer keys in Schoology, the learning check that's in Schoology is all just about writing equations of lines. If you have any questions on that, let me know.